Assalamualaikum warahmatullahi wabarakatuh. My name is Afiq Junaidi Bin Jazlan, metric number 1727681. Now I will be presenting about my final year project 2 presentation. My title is Mechanical and Physical Properties of Hardened Concrete, Incorporated Dredged Sediment as Fine Aggregate Replacement. My supervisor is Dr. Siti ALIYYAH binti MASJUKI, and my examiner is Dr. Tahara Ramazan Kasim and IR Dr. Nur Hidayu Kasim. So for my project outline, I have divided into 4 categories. The first one is introduction from chapter 1. Second, methodology from chapter 3. Third, result and discussion from chapter 4. Fourth, conclusion and future work from chapter 5. So for my problem statement, in recent years, the economic activity in Malaysia has caused the natural phenomenon of sediment accumulation. Rivers had been clogged and causing floods in Malaysia that often happen more than twice a year, and there is no dumping field for dredged sediments. As for my objectives, the first one is to investigate the properties of dredged sediment as partial fine aggregate replacement in concrete for sustainable constructions. Second, to determine the mechanical properties of hardened concrete, incorporated dredged sediment through compressive strength test and ultrasonic pulse velocity test. Third, to determine the physical properties of hardened concrete, incorporated dredged sediment through pull-out test. So for my flowchart, first thing first, the material selection and preparation consists of 4 material, which are water, cement, aggregates, and also dredged sediments that will be collected at Sungai Pusu Entrance 3 IIUM. The aggregates will undergo sieve analysis, and the dredged sediments will undergo scanning electron microscope before proceed to sieve analysis. After prepare the material will be proceed with the mixed design concrete and concrete mixing. Then some tests will be done, and molding and curing for 7 and 28 days. Finally, the laboratory test for 7 and 28 days. The mechanical properties test that will be done is compressive strength test and ultrasonic pulse velocity test. As for physical properties of hardened concrete is pull-out test. So this is the location for the collection of samples of dredged sediments. Next, for sieve analysis. The samples used are after passing 600 micrometer sieve. This is to achieve well-graded content. There are 3 tests which are well-graded, gap-graded, and also poor-graded. Well-graded have high permeability. Sieve analysis can avoid segregation and also bleeding. So this is the process for air dry and oven dry. The samples need to be dry to ensure no moisture content in the sample. The sample is dried for a defined period of time at constant temperature. These 2 figures shows the samples before and after dried. The left shows the wet dried sediments, and the right one shows the dried sediments. The cost aggregate also need to be air dry and oven dry. Okay, next for the analysis test, which is scanning electron microscope SEM test. This test is to produce high resolution image of sample surface. This is to study about the microstructure of the sample. This is used at metallography lab IIUM to proceed with this test. The samples need to be coated first because my samples are non-metal, as shown in the middle picture. Okay, this is the apparatus for the microscope that will be used to evaluate the structure and texture surface of the materials. Let's proceed with the concrete mixing. Dry mixing will be done for 1 minute. Meanwhile, wet mixing for 2 minutes. This is to ensure that the concrete is well mixed. After that, the manual mixing should also be done to ensure the concrete not hardened before molding. So this is the process of concrete molding. All of my 20 samples are in a cube shape, which is 150 mm times 150 mm. Before let the concrete harden, vibrating need to be done to ease the workability of the concrete. Vibration is for about 10 seconds only. Next, for concrete curing for 7 and 28 days. This is to control the moisture loss from the concrete and enhance the strength and durability of the concrete, as well as maintaining mixing water in concrete during the early hardening process. As for fresh concrete test, which is slump test, the slump test is about assessing the consistency of fresh concrete. It is used indirectly as a means of checking that the correct amount of water has been added to the mix. Okay, this flowchart shows the hardened concrete test divided into two: mechanical properties test and also physical properties test. As for mechanical properties test, can be divided into two also, which is non-destructive test and also destructive test. Non-destructive test consists of UPV test, meanwhile destructive test consists of compressive strength test. As for physical properties, the test that will be done is pull-out test, which is categorized in destructive test. Next, proceed with the UPV test. UPV test is to determine the integrity and quality of structural concrete, and also to detect honeycomb inside the cube sample. If there are many honeycomb inside the cube, the microsecond will be higher. There are 4 hertz that will be obtained, which are 1 hertz, 2 hertz, 5 hertz, and also 10 hertz. Usually the range of the microsecond is between 36 to 40. Before proceed with the test, the device need to be calibrated to 58.5 microsecond using the reference bar as shown in the middle picture. Next, for the compressive strength test, which is one of the disruptive tests. The aim of this test is to figure out what is the maximum load capacity of the concrete can withstand. The compressive strength test was conducted in a hardened state using a compression testing machine with the pressure of 3000 kilonewton. The average strength was calculated using 3 concrete cubes with the same percentage of dredged sediment substitution of 50% during 7 day and 28 day of curing. After that, the average strength was compared to the conventional concrete cube. Lastly, for pull-out test, this test is based on the principle that the tensile force required to pull out a steel cone embedded in the concrete. The steel cone is embedded during pouring of mold. The force is applied at the embedded end when the strength has to be determined. A total of 8 cube specimens were tested for this test, 4 cube for conventional concrete and 4 cube for the modified concrete. Okay, so for this test, the average will be taken for 2 cube samples only due to limited time and current situation. Hence, every cube samples will undergo this test to get the average reading. Next, I will proceed with the result and discussion that I have obtained. As for the mix design proportion, the concrete mix ratios were calculated to determine the proportions of cement, aggregates, and water used in the production of the concrete. The concrete mixture for this project follows the concrete production of grade C30, and the mix design is calculated using the mix design by Department of Environment DOE method. The optimum water ratio is fixed to 0.5. Next, for scanning electron microscope, the result obtained from the SEM with the magnification of 100, 500, and 2000 as shown in the figure. The material texture was observed and dredged sediments can be seen with smooth and rounded surface texture. Next, for sieve analysis, the finest modulus FM value obtained from the cumulative percentage retained. The dredged sediments, which is 2.95, were classified as medium sand, while the river sands, which is 3.43, were classified as coarse sand. The graph illustrated that the fine aggregate size distribution comparison between dredged sediments and river sands in order to assess fine aggregate grading. The curve for river sands indicate a well-graded graph. Meanwhile, the curve for dredged sediments indicate a gap-graded graph because at least one particle size been completely missing in it. This is because dredged sediments textures mostly are smooth and subtle based on the scanning electron microscope test. Next, for slump test, the conventional concrete slump is 31 mm. Meanwhile, for the dredged sediment concrete is 0 mm. The slump displayed that it is in category of zero slump concrete. Basically, the slump portrays that the concrete maintained the actual shape of the mold, which showed no measurable slump after removal of the slump cone. However, zero slump concrete is used for the production of concrete mass products. As for the conventional concrete, the specified slump obtained was 31 mm and was categorized as a true slump. Next, for UPV test, the table below shows the concrete quality based on the pulse velocity obtained. 50% of dredged sediments replacement gives low pulse velocity for 7 and 28 days compared to the conventional concrete. Based on the overall results, 15% dredged sediments have the higher pulse velocity than conventional concrete. Thus, this meaning that the higher velocity of pulse velocity, the better the concrete quality. This is due to the dredged sediment's smooth and rounded surface texture as a result to weathering effect. The particles and intact in the concrete thus fill up all the gaps and leave very little space. As a result, the velocity was higher when compared to the conventional concrete. Okay, next for compressive strength test. Both types of concrete showed an increase in strength from 7 days of curing to the 28 days of curing. On the 7 days of curing, the graph showed that the 50% replacement obtained the highest compressive strength reading, which is 31.31 megapascal, while the conventional concrete obtained is 27.25 megapascal, which is lesser than the modified concrete. In contrast with the 28 days of curing, the highest compressive strength reading for modified concrete is 31.8 megapascal, while the reading for conventional concrete obtained is 30.67 megapascal. This can be observed that the modified concrete have higher compressive strength for both days compared to the conventional concrete. Lastly, for pull-out test, the specimens were subjected to pull-out test for failure at early age of 7 days and 28 days. As shown in the table, the peak failure load for dredged sediment concrete obtained is 23.42 kN, while conventional concrete obtained 22.31 kN. This shows that the dredged sediment concrete has higher withstand load capacity compared to the conventional concrete. However, this test could not complete yet because test for 28 days of curing is expected to be obtained on 26 January and will be recorded afterwards. So for conclusion, the dredged sediments provide numerous benefits to the construction industry, particularly in terms of green construction development and minimizing environmental issues. In terms of sieve analysis, dredging sediments had a lower percentage of passing than river sands. This shows that the dredged sediments had more fine particles than the river sands. Due to compact packing of concrete elements, the ultrapulse velocity test indicates that the concrete quality is acceptable for 50% replacement of dredged sediments. The hardened concrete of dredged sediments has a higher compressive strength for 7 and 28 days of curing when compared to the conventional concrete. Hence, the utilization of dredged sediments in concrete production is one of the great ways to practice sustainability. Okay. As for the future work, due to the budget and time constraint, there are certain recommendations that may be made for the project in terms of analyzing the dredged sediment as fine aggregate replacement. One of it is several mechanical properties performance tests can be conducted for the modified concrete, such as thermal conductivity test and energy impact test. And last one is the water ratio can be modified to obtain desired workability. The water ratio has an important role in concrete manufacture according to the fresh state results, as previous tests conducted shows that the value obtained for slump is 0 mm due to fixed water ratio of 0.5. Okay, that is all from me. Thank you. Assalamualaikum warahmatullahi wabarakatuh.